Good morning, everybody. Welcome to the webinar series on managing drought in the Southern Plains. I'm Mark Schaefer with the Oklahoma Climate Survey and Southern Climate Impacts Planning Program. I'll be the moderator for today's webinar. We've been having some audio problems again this morning. We think it's working now. So if anybody on the call is having difficulty hearing us, please let us know through the chat box, and we'll try to get you on the line here. We will be joined today by Brian Fuchs from the National Drought Mitigation Center, Craig Story from the West Gulf River Forecast Center, Aaron Abel from the Brazos River Authority, Bob Rose from the Lower Colorado River Authority, and Jim Crosted from the U.S. Army Corps of Engineers, Tulsa District. Margaret Brune, SCIP Program Manager, is managing the webinar. I apologize for our audio difficulties when we attempted this webinar topic before, and again at the beginning here this morning. We believe we have these solved and appreciate your patience and willingness to participate in the rescheduled webinar. We will return to our regular schedule next week. Before continuing, I'd like to remind anyone calling in to please mute your phones, either using the mute button or *6. In addition to the presenters, several state climatologists are on the line, including Mary Knapp from Kansas, John Nielsen Gammon from Texas, Dave Dubois from New Mexico, Gary McManus from Oklahoma, and Mike Borengasser from Arkansas. Mary will give a brief update on changes in Kansas at the end of this webinar. I would also like to recognize the support of those who made this webinar series possible. Chad McNutt with the National Integrated Drought Information System, or NIDIS, David Brown, NOAA Regional Climate Services Director for the Southern Region, and Mike Hayes with the National Drought Mitigation Center. I'd like to briefly recap the goals of this seminar series. We planned these in order to improve communication across our region to help those agencies and organizations that are managing aspects of the drought. We want to ensure that the information presented is timely and relevant. Our presenters will include a combination of scientists, state climatologists, and resource managers. We are always looking for potential presenters, so if you have expertise in a particular area and would like to be a presenter or would like to recommend others we should ask, please contact us. These webinars are an ongoing series that will occur on the second and fourth Thursdays of each month. Our next webinar will be December 8th. Each webinar will include an update from the Drought Monitor, authors, and state climatologists. Each will have a discussion topic based upon the topics of greatest interest as indicated by the poll, subject to the availability of presenters. You will now see on your screen a poll for future topics. Please cast your vote for the topic you would like to see next. Cattle and livestock is planned as the focus for the December 8th webinar. If you'd like to suggest additional topics that are not on this list, you may do so through typing in the dialog box on your screen. We will incorporate these suggestions in future polls. I would like to mention on this one, we have added this new topic, long-range seasonal to annual forecasting. This was the workshop that was concluded yesterday in Fort Worth, Texas. Or rather on Tuesday, there were a number of discussions and participants found that to be of interest, so we've added that as a potential topic as well. You may ask questions or make comments at any time through typing in your dialog box. Each webinar is recorded and posted on the SCIP YouTube channel. The PowerPoint slides are posted on the NIDIS Drought portal, drought.gov, in the Southern Plains section. A 2-page summary will be prepared following the webinar, as with the others, and will be available next week on the NIDIS portal, SCIP website, and SCIP Facebook page. We will put up a list of resources, including these links, again at the end of the presentation. I will now turn it over to our first presenter, Brian Fuchs from the National Drought Mitigation Center, for an overview of drought conditions and outlook. He will be followed by water resources topic presenters, Craig Story, hydrometeorology and support forecaster with the West Gulf River Forecast Center, Aaron Abel, senior water resources planner with the Brazos River Authority, Bob Rose, meteorologist with the Lower Colorado River Authority, and Jim Crosland, chief of the Water Management Section of the U.S. Army Corps of Engineers, Tulsa District Office. So we have a lot of material to cover, so we'll get right into it here with Brian.
All right, thanks, Mark, and good morning, everyone. Again, I'm Brian Fuchs. I'm a climatologist with the National Drought Mitigation Center and also author of the U.S. Drought Monitor. We'll go right into things here with the first slide. Here's the overview of the U.S. Drought Monitor that came out this morning. And from our last call that we had several weeks ago, you can see some significant changes, especially in eastern Oklahoma and into portions of northeast Texas, where over the last 30 days especially, and even into the last 30 to 60 days, we've seen several rain events come through this region with significant rain events, especially in some of these areas. This was the biggest rain events they'd seen in the last year. So slowly but surely we're putting a dent in the drought. And go to the next slide, we can see a regional view of the southern plains. And you can see even in portions of eastern Oklahoma and into Arkansas, they're drought-free. Some of the D4 down in Texas and in Oklahoma has been eliminated over the last month, and we do see the drought intensity lessening. Not to say that conditions are great or we're anywhere out of the woods, but right now we're in a pattern where we've seen substantial improvement over the last several weeks. Right now, currently, only 29.43% of the region is in D4 compared to just 3 months ago where it was right at 54%. Go to the next slide. We can look over to the west a little bit. Some pockets of abnormally dry conditions over in Oregon and Washington, but mainly in the desert southwest of Arizona, New Mexico, and into portions of Colorado. We have seen some improvement in these regions as well, and this goes along with the storm systems that have been catching not only the southwest but into the southern plains over the last several weeks. Go to the next slide. We have our change map here that we're showing, and what we have right now is looking at the last 4 weeks. In the upper right-hand portion of this slide, you can really see the improvements that were evident across eastern Oklahoma, where 2 to 3 category improvements on the drought monitor, and even into Texas, you can see with the light green at least a 1-class improvement in several locations. Going into the middle panel of the slide over the last 3 months, definitely you can see the improvements over Oklahoma into Arkansas, portions of Louisiana and Texas, where 2 to 3 category changes, even up to 4 category improvements in portions of eastern Oklahoma and Arkansas over the last 3 months. And through this time frame, that's when we've seen the most significant rainfall, like I mentioned, over the last 30 to 60 days. And with the La Nina pattern setting up, this improvement that we see now can be very important as we move forward. Next slide. Here's the 5-day outlook. There's a fairly significant storm system that's starting to develop over the Great Basin and Rocky Mountain regions, and you can see as that trough dips down into the southwest, there's a fairly good chance of precipitation all the way through Arizona and the Four Corners regions, reaching into the central and southern plains, and also extending into the southern U.S. as we move past this 5-day period. Associated with that, in the lower left-hand panel, you can see temperatures are going to drop significantly with a fairly good push of cold air coming out of Canada, with departures anywhere from 15 to 18 degrees below normal for this time of year. So as this system moves through over the next 5 days, we're starting to get several waves of energy already pushing through, looking at some significant rain events, snow in the areas where it's cold enough for snow, and I know it's been mentioned already that maybe some icing events in portions of the southern plains as this pushes through. Next slide. Over the next 8 to 14 days, we continue to see the remnants of this system with the cold air in place over the western U.S. Significant cool down compared to what we have seen. In the 8 to 14, you can see in the lower right as the system moves further to the east, the areas that were not highlighted on the previous slides, you can see that system move through, and there are above normal chances of precipitation anywhere from the northern plains down through Texas and the southern U.S. all the way up into New England. So this is a fairly good storm system moving through. It looks like there's going to be significant precipitation associated with it. And so this trend over the last several weeks of improvements to the drought intensities in some of our main drought areas looks to continue. Next slide. Here's our monthly outlook and then our December, January, February outlook. You can see in the upper panels for December, we're looking at this cold pattern, this trough to continue over the western U.S. with temperatures expected to be below normal. and above normal temperatures from Texas all the way through the southeast and up and through to the mid-Atlantic. During this time frame, though, we do see on the upper right-hand portion of the frame above normal chances of precipitation all the way from North Texas and Oklahoma into Arkansas and southern Missouri, and really seeing that dry signal being pushed further to the south, catching South Texas along the Gulf Coast and into the Florida Peninsula. The seasonal forecast, the bottom two frames for temperatures, we see that La Nina signal continuing with above normal temperatures expected through the southern plains all the way from New Mexico to Florida and up into the mid-Atlantic. And we're looking at the dry conditions to establish themselves as well through the winter. It's usually a fairly dry time of year for many of these locations, but it was the start of the drought that we really started seeing to build last year. So this La Nina pattern is becoming more evident and continuing in the long-range outlooks that we see. If we go to the next slide, the seasonal drought outlook was also updated and released this morning. And what we can see through this here is really the impact of the storm system that is going to be influencing this region over the next several days, with some improvement and improvement categories over Kansas, Oklahoma, and extreme northeast Texas and northern Louisiana. This is associated where the forecast models are projecting the greatest precipitation, and we also can see some potential improvements in the northern plains and upper Midwest, as well as in portions of Arizona. What we also would like to highlight on this image is where we see the development taking place, and that's pushing up into the Carolinas and all the way down into the Florida Peninsula. And this is making sense with the recent storm tracks and also with the seasonal forecast all the way out through February now of the southern tier of the U.S. being in the best chances for below normal precipitation. So all in all, looking at the current conditions and where we've been in the last month, we have seen some improvement through the region. We are continuing to see some improvement as these storm systems break away from a typical La Nina track, and we see portions of the southern plains being influenced with these rain events as they come through. But still, the longer-term pattern does not show a consistency with these improvements continuing through the winter months. And I think that's it for the update. And we'll go into the featured U.S. Drought Monitor product. And right now, what we're doing with this is highlighting the U.S. Drought portal at www.drought.gov. And there are more monitoring tools available on water supply and water availability from the NIDIS portal. And what I've done is I'm just going to highlight a couple of these, and if you're interested in more information from this, please go to the U.S. Drought portal, and there are many different tools to look at and a great deal of information, especially associated with water monitoring and water availability. So the next slide, again, you go to the top menu where we go to the current drought, and you'll get the menu on the left panel showing the different products and the hosting agencies. And this is just the highlight of the USGS and looking at the stream flow percentiles in different parts of the country. This one's dated a little bit. It is from earlier in the month, but this is where you can get a quick snapshot of river basins that are in different drought status based on their percentiles. Next slide. Again, this is on the U.S. Water Monitor site. You can look at stream flows over the last, the current day, the 7-day, the 14-day, the 28-day. And this coincides with the previous slide that you can get an idea strategically on hydrological impacts around the country based on drought in their region. And again, you can see at the top tabs, you can also look at reservoirs, groundwater, and the forecast. And as we go into the winter months, the snow tab becomes more important as well. Go into the next frame. And the USGS Water Watch page is also very helpful. And it's giving you an idea not only of flooding events, but current stream flows, drought, past flow and runoffs. And there's also different tools in here under that toolkit and the animations where you can see some of these activities in a loop and it gives a user a good idea of hydrologic conditions around the country, and again, in a quick snapshot. And I think that is my last slide. Yes. So this information, again, can be found on the NIDIS Drought portal at www.drought.gov. And I'd also be able to answer any questions people would have with regards to these. And with that, I'll pass it on to Greg.
Well, good morning, everyone. I have been asked to speak about the water supply situation in the Rio Grande, covering a good part of southern Colorado and New Mexico into deep south Texas. So if you go on to the next slide. As way of introduction, the Rio Grande gets its water from two primary weather phenomenon. The primary one, of course, is snow melt in the spring from snow that falls in the mountains of northern New Mexico and southern Colorado from the fall all the way through winter and early spring. And the second source, of course, is rainfall during the late summer monsoon season. Next slide. First thing I'd like to do is recap last year that kind of set the table for the serious drought conditions in New Mexico they're experiencing right now. It was fairly dismal water supply-wise for the winter of 2010 into 2011. The northwestern part of the Rio Grande, covering southwest Colorado, fared the best with 50 to 60% of its average flows coming from snow melt from last year. The northeastern part of the Rio Grande, mainly the Santa de Cristos in Colorado, averaged up only about 20% of its normal flows from snowmelt. New Mexico came out very dismal with an average of only about 14% of normal stream flow from snowmelt from last year. Next slide. The mid to late season snowfall never did materialize, especially in the middle and lower elevations, leaving well below average snowpacks, especially in New Mexico for the season. Higher elevation snow did accumulate within the Colorado portion of the upper Rio Grande Basin, and they fared the best. Far below average snow accumulation occurred area-wide, resulting in drastically reduced flows within the Rio Grande Basin down through New Mexico. So that, combined with the real hot, dry summer we just had, really set the table for the conditions that we're experiencing now. Next slide. For the first 10 months of 2011, New Mexico has had its second driest start of any year on record. The statewide average precipitation has only been 63% of normal through October. And so far this month of November, well, actually now it's December 1st, but in November, New Mexico has been wetter than normal in the far northwest and northeastern sections, including parts of the upper Rio Grande. It has been much drier than normal, though, across the rest of the state, which has affected portions of the Pecos River and the lower part of the Rio Grande in New Mexico. This past summer's monsoon rains were generally below normal. They got some, but not as much as what they had hoped in New Mexico. Next slide. This is just a chart that I got courtesy of Ed Velasco, our senior service hydrologist in our sister National Weather Service office out of Albuquerque. It shows that from January through October of this year, what some of the precipitation deficits have been in the Rio Grande Valley and southern New Mexico. You can see that Tatum, New Mexico, is nearly 10 inches below normal for that time period. And some of the others included Albuquerque at the airport there, where they had over 4 inches deficits, in Glenwood, having only 5 1/3 inches of precipitation. Their departure normal was 13.4 inches of rainfall. There's going to be a new graphic put on their drought site on their website from the National Weather Service in Albuquerque soon. If you go to the next slide, I'll show you the last one that was available, showing the January through September 2011 precipitation. You can see that especially the southeastern portions of New Mexico only had 20 to 40% of its percent of normal precipitation. There's only a few pockets in western and northern New Mexico that had greater than 100% of its average rainfall. Much of the state, though, very poor conditions in terms of the amount of precipitation has occurred so far in 2011. Go ahead and go to the next slide. This is what occurred in November, the percent of normal precipitation. You can see that from the storm that occurred on around the November 25th area, they did get above normal precipitation over southwest portions of New Mexico. And of course, throughout the month, the northwest parts of the state of New Mexico into southwest Colorado had fairly close to normal precipitation. The northeast parts did as well. But again, much of east central and southeast New Mexico into southwest Texas and looking down to Rio Grande into Texas, below normal precipitation occurred. There were a few pockets of near normal rainfall near Del Rio, Texas, into the Texas Hill Country, but you really had to go into extreme northern Texas into Oklahoma and Arkansas to find significant above normal precipitation. Next slide. Here's the latest stream flow map that I got from the U.S. Geological Survey in New Mexico. You can only see that there was one spot in northwest New Mexico that had much above normal percentile of flows right now. Everything else was in the 25 to 75% range or below. The worst stream flow conditions, of course, being on the Pecos and southeast and east central New Mexico, with what would be considered near normal flows over northern New Mexico at this time. Next slide. Downstream in South Texas, the Rio Grande and its tributaries are at or below its base flow conditions. If you look at Amistad Reservoir near Del Rio on the Rio Grande, it has about 84% of its capacity right now. Not too terribly bad, but if you go downstream to Falcon Reservoir in deep South Texas, they're at only 42% capacity at this time. And you have to remember, this is a significant drop because just a couple of years ago, a couple of tropical storm systems moved through South Texas and they were releasing tremendous amounts of water from Falcon. So we've had a complete flip-flop in deep South Texas in the soil moisture conditions. And Redwood Reservoir is only at 3% full at this time, and the Pecos drainage. Next slide. Here's the latest Texas stream flow map, and again, a lot of red circles showing much below normal stream flow conditions in terms of percentile. I know Bob Rose is going to be talking about the situation on the Colorado, but you can see the large number of red dots in central Texas back into the Texas Hill Country. Things are a little bit better in terms of flows in North Texas at this time, where we have had some timely rainfall over the last couple of weeks. Next slide. So far, this snow season, which started about a month ago, it appears that a lot of the mid and high elevation snow-tell sites are showing snow water equivalents, especially in Colorado over the San Juan Mountains, are tracking above what they were last winter. The average in Colorado is 90% of normal at this time. The sites in New Mexico are tracking higher and receiving snow much earlier than they did last year. But again, remember, last year was a real down year. So far, 20% of the annual normal snowpack has been established over northern New Mexico into southern Colorado. So far, so good for the upper Rio Grande drainage. Soil moisture down to the 8-inch and 20-inch levels seems good in the Colorado snow-tell sites, for those that have sensors anyway. But they are still very dry in the New Mexico sites, indicating that much of the snow melt in the coming spring will recharge soils and shallow aquifers when the soils warm up next spring. So it looks like even though the flows might be there, a lot of the snow melt is actually going to be going to recharge the soil moisture, as opposed to actually seeing flows getting downstream from Albuquerque and on past. Future snowfall this cold season, of course, depends on La Nina and what type of weather pattern actually develops. The good news there is that there's a major storm system that is in southwestern Arizona right now. In fact, I was noticing they are getting lightning strikes north of Phoenix. And looking at the radar, there's a wide swath of precipitation over central Arizona now. This is heading towards at least northern New Mexico and southern Colorado, where winter storm watches and warnings have been posted. So there could be significant snows over the next 4 or 5 days over northern New Mexico and southern Colorado. So La Nina or not, we've got yet another storm system that looks promising for at least the northern half of New Mexico and Colorado here between now and, say, Monday. Next slide. Here's what the November actual precipitation looked like. This coming from our AHAPS website. You can see that much of southeast New Mexico and portions of east central New Mexico was lacking. Looked pretty good for southwest New Mexico, as well as extreme northern New Mexico into southern Colorado. Much of central and parts of north Texas had some fairly good rainfall, but by far and away the heaviest precipitation is stopped at the Red River and occurred across portions of Oklahoma and Arkansas. Even East Texas had some rainfall. And the QPF, as Brian showed just a moment ago, has some significant QPFs for east central and northeast Texas, especially late this weekend into early next week. Next slide. Here's the winter outlook. Again, a recap of what Brian had shown. Again, it shows generally below normal precipitation is expected across a good part of the Rio Grande drainage until you get into northern New Mexico and southern Colorado, and there it looks promising that there could be some pretty good precipitation there this winter. The thing I want to remind everyone, the rate of the temperature rise in spring plus any sublimation that occurs will determine the 2012 final water supply outlook numbers and the stream flows in Colorado and New Mexico. 2 years ago, the outlook for the spring snowmelt looked really promising. But then in northern New Mexico and southern Colorado, they had a week of very windy weather, and there was significant sublimation, so the amount of actual stream flow from the snowmelt was very low, especially compared to our outlook. So it's a lot of things that can enter into the final determination of who gets how much water in the Rio Grande next spring, even if you have a good snowmelt year. And with that, we'll go to the next slide. If you have any questions or comments, feel free to send me an email. There is the website where you actually can see the precipitation displays that we use that are generated from our MPE program here at the RSC. So with that, I will pass it on to our next presenter.
Thanks, Greg. This is Aaron Abel of the Brazos River Authority. I'm a Senior Water Resources Planner here. And today I'll discuss the impacts of the current exceptional drought on the Brazos River Authority water supply system. I'll talk about our water supply system configuration, its attributes and general operating principles, and also talk the direct impacts of the drought on the system and the evolution of the drought. Also talk about projections moving forward and what we might see if conditions persist. Next slide. This slide depicts the Brazos River Authority water supply reservoirs in a geographic context. Brazos River spans from the Texas Panhandle along the Caprock, approximately 800 miles southeast through central Texas to the Gulf. 11 reservoirs compose the system, 3 owned and operated by the Brazos River Authority as water supplies reservoirs. These are Possum Kingdom, Granbury, and Lake Limestone, shown in red. And the 8 that are owned and operated by the Corps of Engineers that are used as both flood, storage, and water supply reservoirs, and those are shown in yellow. The Brazos River Authority holds contracts and water rights permits to store water at each of the core reservoirs, and we also operate the Williamson County Regional Raw Water Line that transfers water through a 48-inch pipeline from Lake Stillhouse Hollow to Lake Georgetown with a maximum transfer rate of about 44 MGD. Demands on the system come from the lakeside use and downstream use, municipal demand, and demand from industrial and electric power generation really dominate the water use types within the basin. Irrigation use accounts for a small portion of the total water use throughout the system. And we have large industrial, municipal, and electric power generation demands located in the lower basin just west of Houston. Downstream releases for these demands are generally made from the larger reservoirs, with the other reservoirs operating mainly for local supply. Next slide. Now the impact of the drought on the system. This graphic shows the locations of all of our water supply reservoirs in the circles color-coded with the current reservoir capacity of each reservoir. And we've also added the U.S. Drought Monitor levels as a base layer to the map. As you can see, most of the reservoirs are primarily between about 40 and 75% full. One thing to note is that we have been somewhat fortunate to receive some rainfall in the central and upper portions of the basin. These are the areas that range from moderate to extreme, the drought intensity levels. In early October, many locations in this portion of the basin received anywhere between 3 and 8 inches of rainfall. This event added about 2 months of additional supply under fall and winter conditions. Additionally, over the last several weeks, we've had portions of the upper and central basins receive some continued rainfall, adding to the soil moisture in these areas, but runoff has been minimal with these events. Reservoirs further downstream in the lower portion of the basin have not fared as well, with many experiencing historic low lake levels. Next slide. This graphic really puts in perspective the impact of the drought on hydrology, specifically related to reservoir inflows. This is the cumulative inflow plot over the last 14 months for the reservoir system. The vertical axis is the cumulative inflow in acre feet with time and months along the horizontal axis. This is the sum of the inflows in the period over all reservoirs in the system. The black line represents the actual cumulative inflow beginning in October 2010 and ending on November 28, 2011. The other cumulative inflow sequences in purple, red, and blue represent the 3 lowest historical 14-month sequences spanning from 1900 through 2007. The drought of the late 40s into the late 50s is a critical drought period with which water supply in the state is typically based upon, so it's not a surprise to see the 14-month sequence from October 1950 through November 51 in this plot. We also see some of the shorter, more intense droughts experienced in the early 1900s as well. As you can see, the current active cumulative inflow sequence in black represents the lowest 14-month inflow sequence in recorded history, with approximately 100,000 acre feet less inflow than the previous 14-month record low sequence. And another item to add to put these numbers into perspective is median 14-month inflow for the system is around 2.5 million acre feet. So we've seen roughly about 16% of the median 14-month inflow in this current period. Next slide. This figure is a result of analysis that uses gauge stream flow data measured at the USGS gauge along the Brazos River near Hempstead to illustrate the influence of water supply releases on the stream flow in the Brazos River over the past 7 months. The Hempstead gauge is located about 200 miles inland from the Gulf and was ideal for this analysis because the gauge is located downstream of our major tributaries of the Brazos and upstream of the major water users situated in the lower basin. The area shaded blue is the estimated volume of water that was released from upstream reservoirs, adjusted for losses and travel time to the gauge. The yellow area is the estimated flow that would have been present at the gauge without the releases from the reservoirs. This estimate is made up by subtracting the routed reservoir releases from the total gauge flow. The combination of yellow and blue shaded areas represents the actual measured flow of the gauge. Periods between late July through around mid-September indicate extremely low stream flow in the absence of water supply releases. This flow is mainly composed of return flows and groundwater discharge to the river. The take-home point here is the river flow would have been extremely low if there weren't for the release of stored water from reservoirs for downstream use in the lower portion of the basin. Next slide. Now transitioning to the evolution of the drought in terms of water supply, I'm going to show a progression of these basin cylinder plots to show the response of the system due to the drought over the past year. Each cylinder represents the location of each reservoir in the basin. The left portion of the map represents the northern part of the basin, the right, the southern part, with the Gulf at the far right. The height of each cylinder is proportional to the actual capacity of each reservoir. So essentially, the taller the cylinder, the larger the reservoir capacity. The blue represents the full storage, with the white representing empty storage. So these are the conditions in late October 2010. The system as a whole was relatively full, approximately 96% full. And this was due to a large part from inflows produced in late summer to early fall 2010 by several tropical disturbances. Some of our reservoirs rose above flood storage at this point as a result of these disturbances, and most were greater than 90% full. Next slide. Now, fast forwarding to current conditions, this is the system water supply status as of November 30th. Percent full and drawdown values are provided in the table in the upper right. You can see reservoir drawdown values range from around 5.5 feet up to about 23 feet in the reservoirs. The system total capacity currently stands at around 62% full. Downstream releases were initiated from the system in mid-April when flows downstream in the lower part of the basin reached critically low levels and many entities could no longer draw water under their own water rights from run-of-river flows. With the onset of these releases and high lakeside demand and excessive evaporative losses, 7 of 11 reservoirs in the system have reached historic low lake levels. Due to the decreased capacity, we've entered into various stages of our drought contingency plan, which is a 3-stage plan with targeted water use reduction goals at stages 2 and 3. The goal for stage 2 is around 3% and with 7% reduction at stage 3. The plan does give the ability to modify these goals, and the drought contingency triggers operate on individual reservoirs with lake levels being the trigger, as well as reservoir systems with the combined storage trigger. Lake Somerville entered into stage 3 in early September, and currently we have Lake Proctor, Lake Georgetown, and Lake Limestone in stage 2. Lake Proctor was about to enter into stage 3 when the early October rains provided relief and the lake level rose around 4 feet. The entire system entered into stage 1 trigger in early August when the combined storage of the system reached 1.395 million acre feet. Next slide. Now for projections assuming minimal inflows and high evaporation, continued high water use. This is what we project for the end of February 2012 here. We're assuming continued releases through the next several months and worst case scenario for inflows and evaporation. We're projecting the total system capacity will be around 56% at the end of February. Next slide. And now looking forward to the end of September 2012, we anticipate reaching the stage 2 drought trigger for the system in March to April 2012 timeframe, and by the end of September 2012, we could be below the stage 3 drought trigger if things persist. With the total system storage, it's about 35% full and projected drawdowns between 10 and 50 feet. The stage 3 trigger is determined for each reservoir in the system by taking either 30% storage or the volume required for 1 year's supply, whichever is greater. Stage 3 for the total system represents the cumulative storage for stage 3 over all reservoirs in the system, which is about 37%. Once stage 3 conditions are met, mandatory water use restrictions and pro rata curtailments of contracts are possible. Currently, we're in the mode of planning for the worst, and we hope these projections are wrong and we pick up some rainfall into the winter. I think this does it for my presentation. I think Bob Rose of the Lower Colorado River Authority is going to present next.
Well, thank you very much. Good morning, everyone. I'm going to talk a little bit about what's going on the lower Colorado River. And as you see on the next slide on this map of Texas, I'm talking about the Colorado River in Texas. Just to clear up any confusion, there's no connection to the Colorado River across the Rockies that flows into the Gulf of California. On the map on the left, that area in blue denotes the Colorado River basin, but the lower Colorado is more the lower half of that, if you will, in the inset there, generally from just to the east of San Angelo and below Brownwood, and then the area across the hill country, and then funneling into an area around Austin, and then along the river down to the Gulf. LCRA is a little bit different than BRA in that about 2/3 of our water releases go toward agriculture, and about 1/3 of our water releases go to municipal and industrial customers. On the next slide is a little bit closer in view of the lower Colorado River basin. There are several dams up above our lower portion of the river, but the river generally stretches from just below Lake Ivy and then bends on around through around the San Saba area, and then down through Austin and down into the Gulf of Mexico. The watershed of the Colorado River is about 180,000 square miles. On the next slide, you'll see that LCRA operates a system of 6 dams and lakes, often referred to as the Highland Lakes. At the top, we have Lake Buchanan, followed by Inks Lake, Lake LBJ, Lake Marble Falls, Lake Travis, and Lake Austin, and then the river below Austin. Of the 6 lakes, only 2 of them have water storage. That would be Lake Buchanan and Lake Travis. Lake Travis is also a flood control reservoir as well. You can see on this picture as well that some of the major tributaries coming in, like the Pedernales River and the Llano River coming into Lake LBJ. On the next slide, wanted to talk a little bit about how the drought has affected our river basin over the past 14 months. This slide shows the rainfall departure from normal between October 2010 and September of this year. And you can see that for much of the basin, rainfall was more than 20 inches below normal. And in fact, for many areas, this was one of the driest years, if not the driest 12-month period ever recorded, going back to 1895. On the next slide, this is the current drought monitor, and in the central part of the state, you still see that there's quite a bit of exceptional drought. And in fact, on the next slide, you'll see the inset of our river basin, and that currently still about 3/4 of the watershed, including the lower river, are in exceptional drought. The recent rains that have occurred across the area really not changed the situation very much since last summer at all. In fact, if you look at the next slide, you'll see that this is rainfall since this past October, going back about the last 8 weeks. This is the rainfall departure from normal. And even though many areas have seen between 2 and 5 inches of rain, we've had a few spots in the hill country with even a little bit more than that. Rainfall overall has just been generally normal. To the west of I-35 and southeast of I-35 down to the coast, rainfall has still been between 2 and 6 inches below normal. There's very little inflow coming in, especially in the river downstream below Austin. On the next slide, I wanted to talk a little bit about inflows and how we measure inflows. There are 4 major tributaries into our Highland Lake system. First is the Colorado River up near San Saba. The next is the Llano River at Llano. Below that is Sandy Creek near Kingsland, and then finally the Pedernales River at Johnson City. Adding those 4 points together gives us our cumulative inflows into the Highland Lakes for potential storage. And as you'll see on the next slide, the inflows that we have seen over the past year are among the very lowest on record. What you're seeing here is a comparison between what would be normal or average in the blue bars by month, and in the gray bars what occurred actually in 2009 as far as the cumulative inflows, and the green bars in 2011. In the early part of this year, between January and March, we were running well, actually January and February, we were running a little bit ahead of 2009, but the beginning in March, inflows were even less than what we saw in 2009, which was among some of the lowest in history. As we got to the spring months and missed out on the spring rains, you could see how the inflows really started to fall off. In fact, by June, July and August, you can't even see the green notation there. And I actually put in the actual volumes there that you could see. By July, we were down to 720 acre feet. By August, only 367 acre feet. In September, 650. It's interesting to note that August was the 3rd lowest monthly inflow ever into the Highland Lakes. September was the 4th, and July was the 5th lowest. Now, we did pick up some rains in October, but still, it was only about 28,000 acre feet. So we still are much less than where we were in 2009 and well below average. Right now, we're on pace to record the lowest calendar year of inflow ever into the Highland Lakes going back to 1940. So a very serious situation here as far as the rainfall deficits go and the inflows into our lakes. On the next slide, here's just a look at the way our system is currently sitting. Again, Lake Buchanan and Lake Travis are our 2 water storage reservoirs. The lakes in between are generally just pass-through reservoirs for hydroelectric power. Lake Buchanan currently has a storage of 330,000 acre feet. It's about 38% full, currently at its 3rd lowest elevation in history. Lake Travis is at about 407,000 acre feet. It's at 36% full, and again at the 3rd lowest elevation in history. As a system, we're at about 737,000 acre feet, or about 37% full. And on the next slide, you'll see that LCRA operates its river system by a water management plan that was approved by the state of Texas. On this plan, there are different trigger levels which require LCRA to do certain things depending on how low that combined volume gets to. And you can see that we started off earlier this year where the combined storage was well over 1 million acre feet, but because of high demands, the very low inflows, the very high temperatures, and record high evaporation, the levels of the 2 reservoirs dropped very quickly over the summer months. In fact, it's interesting, evaporation rates of our area were calculated to be even about 13% higher than what they were even in 2009, which was a very hot and dry year. At this point right now on our water management plan, we're at a very interesting crossroads because what you're seeing here is a forecast going off to the right with the two lower red dashed lines being the very dry scenario forecast over the next 5 to 6 months. The green line would be if we were to get into a wet scenario and the lakes start filling. Over the last 12 months or so, we have been tracking very close to this lowest red line, which has been one of the driest, of course, inflows on record. If this drought were to continue, our forecasts estimate will be somewhere around 700,000 acre-feet by January 1st and reach a level near 600,000 acre-feet sometime around April or May, which is very significant for us. At that point, according to our water management plan, this would be declared a drought worse than the drought of record. In other words, even worse than the drought of the 50s. At that time, according to the plan, all water for agriculture will be cut off, curtailed, and then all firm water customers will be asked to reduce by 20% pro rata curtailment. So it's at a very interesting time if these dry conditions do continue, and we do indeed reach the 600,000 acre-foot mark sometime this spring. On the next slide, I wanted to show you one other effect of the drought, and that is the very high salinity levels in Matagorda Bay. Because there's been so little rain this year, especially into the lower basin, and very little water released out of storage for the bay, the salinity levels within Matagorda Bay, and it's generally the western part of the bay there, they're either as salty or in some cases even saltier than the Gulf itself. And we thought the conditions might improve a little bit this fall, but they haven't. The salinity levels are still very high in that bay, and really this is indicative of most of the bays along the Texas coast. Finally, one last slide. This is from Lake Travis around the Hurst Creek Arm. This was actually just taken yesterday. That's Hurst Creek Marina over there that all the boats have been pushed out to in that little area of water. You can see really how low the lake has gotten. That's Graveyard Point in the foreground for anybody who's very familiar with the lake. But a very interesting situation. It was only back in 1991 that this area was really inundated with water when Lake Travis reached its highest level ever. But right now we're looking at the third lowest level ever. So that's it on my presentation, and I'll turn it over to the next speaker.
Thanks. I'll try to be brief, be brilliant.
Yeah, I needed something in the word.
Just like to comment, please make sure that your phones are muted so that we can hear our speakers.
My cord caught in my zipper.
All right, this is Jim Crossan with Tulsa District Army Corps. Next slide. Someone does need to mute their phone. This slide shows you our website, which is a great resource. It also shows you the district footprint, Oklahoma, southern Kansas, and parts of Texas. Next slide, please. We've had great improvement the past few weeks from rainfall runoff, and we've transitioned from the flash drought to really almost normal conditions in the eastern part of our district. There's a few lakes that are still very low storage out west, and you can see those, Canton Lake and Great Salt Plains, and then John Redmond in Kansas. But overall, the changes of the past few weeks, our southern neighbors aren't so fortunate. We've had a lot of runoff and probably some more this weekend. Next slide, please. Over the summer, this picture was taken 20 September upstream of Lake Texoma. That's the Red River, and there's nothing in the thing. And that was how it was all summer during this quote-unquote flash drought. And I'll talk a little more about Lake Texoma in a second. Next slide, please. And Lake Texoma is just one of the 49 lakes and locks and dams that we operate, but it's a good example. 20% is the inflow, 20% of average. That had tremendous impacts on water supply, hydropower, and recreation at Lake Texoma. As you all know, the federal reservoirs have multi-purposes, and all the purposes were negatively affected in this drought. Next slide, please. The Corps in general has what are termed drought contingency plans. Each Corps project has the plan. It's a basic reference for management processes during a water shortage. And there's 4 levels of response, which are progressively initiated as the drought intensifies. Next slide, please. There's level 1, which is an alert phase, pretty much normal operation. Drought level 2, there's expanded action. And the CDMC is the Corps Drought Management Committee. It gets together and starts looking at all the issues and all the stakeholders, coming up with communication plans. We start water storage accounting. We issue notices to water supply users of how much storage they have left. And when the lakes get a little bit lower, that goes to drought level 3, and we had several in that level. And the expanding action is the Interagency Drought Management Committee. And with so many purposes vying for the water out of the federal reservoirs, these processes can get fairly complex. And so we learned a lot this past summer with how to best engage all the stakeholders and how to hold meetings and guide these discussions. Because the reservoirs are operated for specific purposes, and these things have to be balanced and communicated to all the stakeholders. Drought level 4 is simply drought level 3 on steroids. Next slide, please. And there are details on those drought levels on the presentations that will be posted later if you're interested. Some of the general impacts of the 2011 drought on Corps of Engineers reservoirs, specifically Tulsa District. Our district holds 50% of the Army Corps of Engineers water supply contracts, and that's interesting. So there's quite a few stakeholders with each of these lakes, and they need feedback on their usage rate versus the remaining storage. So that was a challenge to gather that information and to give those stakeholders feedback on their water supply remaining. And we had a lake that, if we hadn't had the rains the past few weeks, it would have been empty by Christmas, and a major stakeholder would have been furloughing hundreds of employees. Luckily, that lake had rain and is well in the flood pool at the moment. Water storage accounting, I mentioned that. Something we ran into this summer was record evaporation. We're familiar with normal evaporation, and we're familiar with drought evaporation. This summer, we had evaporations that exceeded our previous drought evaporation. And I don't know if it was extremely low dew points combined with the very high temperatures, but, you know, typically what we call our drought evaporations are 40% higher than our average. We saw 18% higher than our drought evaporation. And that diminished the storage rapidly, especially July through September. So those will go into our statistics and be considered for future planning. Something else that occurred in 2011 was blue-green algae. And for those of you who aren't familiar with it, it's considered a toxin. So the Corps has to issue alerts to get folks out of the reservoirs, don't go in the water. And you can get sick from it. And in extreme cases, there can be fatalities. That's simply exacerbated by no inflow, high temperatures, stagnant pools. We saw a lot of that. One other thing that occurred in 2011 were a lot of challenges with endangered species and providing environmental flows, specifically with reservoirs that don't have allocations. poor water quality or environmental flows. So a drought will expose all of those issues, and you will be engaging the U.S. Fish and Wildlife Service or your state service on those issues. Simply a give and take and operating those projects according to the laws, and just trying to get everybody on the same sheet of music. That's the biggest challenge during a drought. Next slide. We're wrapping up here. Pine Creek Lake is in southeastern Oklahoma. We had a record low pool there. There's a major corporation that uses that water. That pool has since recovered. Non-native fish challenges. We do have trout fisheries in Oklahoma, believe it or not. And those were a challenge, just keeping those stakeholders informed and trying to use whatever water was available to keep the fishery at least viable. Other than that, next slide. That's a real optimistic picture there of Hula Lake, 2002. Hopefully, Tulsa won't see a drought like it did last summer. However, we have plans for it and seem to be in better shape with the rains recently. And that seems to be the end of the presentation. Thank you.
Thank you to our presenters. We do have several state climatologists on the line. I know Mary Knapp from Kansas had wanted to make a few comments about situation up there, and then we'll go ahead and open it up for questions. Mary?
Okay, I was just going to do a very short update, and our comment is basically the miracle rains that we got in parts of southeastern Kansas. We did have a number of locations that set not only record precip for the date, but we also had an all-time record precip in one of our locations in Neosho County, which is in that southeastern corner, and that, of course, is reflected in the increases in inflow in those reservoirs down in that area. Unfortunately, as you moved east and north from that, not nearly so dramatic, although statewide, we were slightly above normal for the month, and of course, that has been very beneficial. What we're watching in particular is in our western areas that had fairly good rains in October. They've started to shut down. This is their dry season normally, but winter moisture, as alluded to with the talks on the rivers, are important in keeping that ground saturated or at least moist, so that the spring rains actually have some benefits. And of course, those are big winter wheat areas. So since the conditions were so dry as that wheat went into the ground, there's a lot of concern about having sufficient moisture to avert winter kill. And so that is a continuing concern in the western parts of the state. That pretty much covers what I had to say.
All right, thank you, Mary. Are there any other state climatologists on the phone that wanted to make any comments? Okay, I know we run long again, but there's just so much going on and such diverse impacts across the region. We're trying to give everybody a little flavor of what everybody's actually dealing with. Looking at the chat box, and I don't see any comments right now. So if there are any others, please type them in the chat box. Otherwise, we'll leave this list of resources up on the screen for a few minutes. And as a reminder, the presentation materials will be posted to the drought portal in the Southern Plains section. And we will produce a 2-page PDF summary of all this information within the next few days, and should have it posted early next week. This webinar is being recorded, and we will have it posted on the SCIP YouTube page, and also the PDF summary will be on our Facebook page. So there are multiple ways to reach us and to see the presentations. Invite everybody to please join us again next week when our presentation will be on the impacts of the drought on the cattle industry. And also mention that to please look for a short survey, which we will distribute soon to gather more of your ideas on how we can continue to improve these webinars and assure that the information is useful to you. So I think that it looks like that's about it. So appreciate everybody's patience, and again, I appreciate your sticking with us and coming back when we had these problems before. I know this is a different time than regularly scheduled webinars. So, so I appreciate everybody, and please join us again next week. So thank you to everybody.